polynomials, okay? However, maybe just something up here on the board. However, if you have a vertical asymptote, that is discontinuity, that is a disruption. I'm trying to draw it up and I have to hop over here and continue. Like one of those, okay? That is a disruption in continuity right there. Horizontal asymptotes, not a disruption. Just a gravitational pull, if you will. Okay? So, the two types we learned in the first semester on that gravity test were whole vertical asymptote, removable, non-removable. Okay, here's what you do. If that top thing there, see that 2x cubed on top? If it factors into x minus 2 times something over x minus 2, we would get cancellation and have a what? We would have a hole in the graph. We're trying to find out which one we have. Now, what if there's not an x minus 2 in there? What if it factors into something else? Then there's no cancellation, and you get the vertical asymptote. All you have to do is figure how to factor the top. All right? Two options. Option number one, do the rational root theorem that we did on the front page, and guess and check until you find one that works. Okay? And if 2 works, great. Wait a second, though. We've got a shortcut. See, on the front page, we had no idea what the solutions were. Start from scratch. On the back page, we know that we are specifically checking 2. How about this for now? Could we plug 2 into the numerator, just the numerator only, and see if it's a 0? Because if the numerator is 0 at 2, then it's a root. Yeah, it's a factor. That's the shortcut. Okay? So shortcut, 2 into numerator. And that would be so much easier than having to do the rational root theorem, which is better than the alternative. But this is a super shortcut. So let's take 2, and let's simply plug it into the numerator and see what happens. 2 times 2 cubed minus 7 times 2 minus 2. Okay, what's 2 times 2 cubed? 16 minus 14. Oh, nice. It's 0. Okay, isn't always, but it is. It's a check mark. Okay, so therefore, if 2 creates a 0 in the numerator, guess what? The numerator is secretly an x minus 2 times some mystery trinomial, right? But that's all you need right there. If 2, the only way, this doesn't happen by accident in math, the only way that 2 creates a 0 is if the x minus 2 is part of the component there. It's hidden there. Okay? So that means cancellation. So the final answer is what type of discontinuity? Oh. Yeah. Or just say, yeah, just call it removable, and you're done. Okay? So looking for the cancellation. Okay? So that's a quick and easy test. So literally, you just have to do these 2 steps to answer this question, and that's it. Done. Okay? Nice, right? Nice right there. So don't do the rational root theorem when you don't need to, but it sure comes in handy for those impossible to factor polynomials. Okay? And we'll only do the cubics, but even the 4th degrees and the 5th degrees and the 6th degrees and the 100th degrees, you can use the rational root theorem. Works for all of them, which is nice. Okay, now the last couple here are pretty easy. Solve the following. All right. Now, to solve this, the first thing we want to do is factor, and even though it's a cubic, you would not want to use the rational root theorem for this. You want to do a shortcut as well. Is there anything we could take out of all 3 of these? X. We can take out an x. Okay, try that first. Okay, handcrafted. Okay. All right, look at this. This factors so easily into what?
X minus 3, x
Minus 3? And plus 2. Perfect. Very nice. So we have 3 solutions if you were doing equals, but wait, this isn't equals. This is what? Okay. Less than or equal to. Okay? So we can do equal to 0. We can do that, but we also have to worry about less than 0. What types of numbers are less than 0?
Negative.
Negative. So we're looking for negatives as well. All right? Here's what we do. Let's do the equal 0 first. That's easy. Okay? X would be 0. And 3. And negative 2. So we have 3 solutions. But here's the thing. Where is it negative? That's where it's equal to 0. Where is it negative? All right? Best way to do this, do a number line test. Okay? Just label that y. We'll just call this equation y. Okay? And this is a number line right here. Okay? This is going to be kind of like the x-axis, actually. So on a number line, what we're gonna do is this. Let's plot these numbers, and on a number line has to be from least to greatest. So who's the smallest? Negative 2. Who's in the middle? 0. And the biggest? 3. If a graph is negative in value, where is it located when you graph it? It is negative in value, right? So it's actually located below the x-axis. Everything below the x-axis is negative value. Everything above the x-axis is positive value. All we're trying to do is find out when is this thing below the x-axis, okay? Here's how we do it. Let's plug in some sample points, okay? Just random test points here. We already marked all the crossings. Aren't these all the crossings of the x-axis?
Mm-hmm.
So we know the crossings. And in between crossings, you're either above or below, all right? So what's the number between negative 2 and 0 we can test out?
-1.
Okay, how about negative 1? What's the number between 0 and 3 you can test out?
1.
Okay, 1. Something less than negative 2.
-3.
Okay, negative 3. You know what? I need a little hint for tomorrow and the next day. If you pick something ridiculous, it's actually easier to calculate. Okay, something really ridiculous. Negative 1,000. Okay, and where we're at.
It was something around negative.
That's good.
It's somewhere around negative 4,000.
Very good, Steve, right there, all right? And up here, 100, 1,000, a million, pick something ridiculous, and I'll show you why. You don't have to actually plug it in. You just have to identify the sign. Start with this one. Plug this in. Ooh, don't want to plug it in there, that'd be long. That'd be difficult. Plug it in here, the factory. What is negative 1,000 plugged in for x? What do you get? Negative 1,000. Just put down negative. 1,000 doesn't matter. What about negative 1,000 minus 3? Negative. What about negative 1,000 plus 2? Negative. Now, it doesn't matter if you chose negative 2.1 or negative 3 or negative 1,000. Everybody in the room plugged it in correctly. You can get a negative times a negative times a negative. And a negative times a negative times a negative is a what? Negative. That must mean that the graph of this equation is located where right now? Below the x-axis. Now, take negative 1, plug that in. You get a negative. Negative 1 minus 3 is negative. Negative 1 plus 2 is positive. And you get a plus, no matter what you choose between negative 2 and 0. Okay? Then this one, you try this one, and you get a positive. 1 minus 3, negative. 1 plus 2. And a positive times a negative times a positive is a negative. And in the last one, you plug in 1,000 or 100 or something ridiculous, and you get positive. 100 minus 3, positive. 100 plus 2, positive. And you multiply all those signs together and you get a positive. All you have to worry about are the signs. So this graph is below the x-axis, then it's on the x-axis, then it's above, on, below, on, above. Hey, just stick with the pen. How about that? Nice little text. Good stuff. All right. So the final answer is, where was it negative or equal to 0 from the beginning of time, starting with negative infinity, all the way up to negative 2. Now, including or excluding negative 2? Excluding, because look, where is it equal to 0? So that is not a parentheses, that is a bracket. What if I leave off the underline on the text? Parentheses, right. Remember the symbol that links to other things we did before in the first semester? Union. And then everything from what to what is negative?
0 to 3.
0 to 3. What about equal to 0 then? Bracket included. Okay? So you just do that little simple test and you know exactly what the graph looks like, basically. Okay? Kind of nifty. Oh gosh.
We don't have time.
All right. Well, I'll give you the short side of this. It's easy. Just use this for your work, for your homework. To find a critical numbers are the roots of the derivative, not the original function. So you take a derivative, set that equal to 0, and then you do the same exact thing that we did in problem A, the rational root theorem. Okay, souvenir. Catchphrase. Souvenir. Short and concise. Only 4 homework problems.